Lesson 19, B. We are moving on to word problems involving the multi-step inequalities that we learned yesterday. So let's just review those common phrases that we need to translate for word problems. Remember these? How do you read that first symbol? Less than. And we usually don't say that. Sometimes we do. But there's other word phrases that we use in life that mean the same thing. Do you remember what those are? Not that one. Not for the less than. Brian? There's is below and is fewer than. How about is greater than? What's some other ways to say is greater than?
Is bigger than?
Is bigger than, or is larger than, or is more than, or is above. How do you read this symbol? The third one. Less than or equal to. So that one would be, how do we say that one normally? Because we don't say is less than or equal to in real life. At most. There's another way. Is no more than. How about the last one? How do you read that one normal in math? Greater than or equal to, so that would be is no less than or is at least. Take a good look at these. We're going to be using these today. Alright, number one. This looks familiar, yes? Mrs. Trouble keeps coming back. She charges her music students $25 per lesson plus a recital fee of $50 that you have to pay no matter what. How many lessons did the student take if she paid no more than $175? Think you can set this up? Greater than or equal to? I want no more than, so I don't want greater than. Less than or equal to. So let's talk about guess and check first. If we have $25 per lesson and a recital fee of $50, if I only have one lesson, that's $25 for one lesson plus the $50 I have to pay no matter what. I'll be paying $75 total, right? If I take two lessons, that would be 25 times 2, right? That's how much it costs for a lesson. That would be 50 plus 50 is $100. 3 lessons would be $125. 4 lessons would be $150. What is the thing that's changing here, that's varying? Which represents what? The lessons, the number of lessons I'm taking or the student is taking. So if I have the number of lessons that is changing, because it could be 1 lesson, 2 lessons, 3 lessons, whatever number of lessons, that's going to be our varying term. That's our variable. Because a variable is something that changes. Yes? So if you have trouble still figuring out, is it going to be 25x or is it going to be 50x? Think about, what's the question asking you? It's asking how many lessons, because we don't know how many lessons. That's the thing that's changing. It could be 1 lesson, 2 lessons, 3 lessons, whatever number of lessons. So here we go. Sean was correct. This was 25x plus 50 because 25 per lesson, that's the thing that is changing, is less than or equal to 175 because I don't want to spend more than 175. I want to spend less than that. No more than would be less than or equal to. I'll go ahead and let you solve this. Solve for x, please. Carlos, will you tell us how you solve this problem, please? From both sides.
And I divided 25x to 125, and then I got x is less than or equal to -5.
Negative?
5.
Good. I'm glad you changed it from equals. It's not equals. Less than or equal to is correct. So we have x is less than or equal to 5. Does that answer the question though? Did it ask for a math problem? When somebody asks you a question, do you answer in a math problem? No, right? How do you answer this question, Sean? As a sentence. And what is your sentence? Exactly 5?
Oh, sorry. It's 20, at least. No more than
no more than 5 lessons. You can say it as no more than, or you can say the student took less than or equal to, or you can say the student took 5 lessons or less. Or at most 5, any of those are acceptable. Any questions about number 1? Alright, let's look at number 2. Carmela wants to buy a digital camera, and it costs above $192.50. She already has $24.75, and she's saving $15.25 each week. And how many weeks will she have enough money saved to purchase a camera? So let's think about this. Is the cost going to change for the camera? No, that's the total number of money, right? Amount of money. So that's going to be our number at the end of the inequality. The money she has now, she's not going to spend any of it, right? She's saving. So is that going to change? Nope, the money she has now is not going to change, so that would be our constant. What is going to change? Which is also, hint, hint, the question they're asking you. The number of weeks is what's changing, and that affects the money she's saving. So 1525 is going to be our x term. So it would be 1525x plus the constant, which is how much money she has now, $24.75, and then above $192.50. How do we write above as an inequality symbol? Greater than. It costs more than $192.50. Go ahead and solve number 2, please. Very good. Mm-hmm. Very nice. Great. X is greater than 11. And your sentence, we want to use the word from the problem because that's easy to do, right? But in this case, it's asking how many weeks. Do we typically say above weeks? Does that sound funny to you? Right, that sounds funny. So what's another way we can answer this problem? What do you have? Good, that's a perfect sentence. It will take her more than 11 weeks. No, not at most, because that would be an or equal to one. At most is less than or equal to. It's actually going the wrong direction too. We want it to be more than 11, not most 11. Okay, any questions, other questions about number 2? Let's look at number 3. This is one we haven't seen before. It rained a total of at least 10 inches. The first day it rained half an inch, then it rained 2/3 of an inch each day after that. For how many more days did it rain? Again, the question is asking you for how many more days, which is also a hint to what is the varying thing here. The total, obviously, we all know that's going to be the total. That's the last number, right? And then the first day it rained half an inch. That happened in the past. Can we change the past? No, that's going to be our constant. And then it rained 2/3 of an inch each day. Keyword each, meaning it's going to change per day. So how do we set this one up? At least, that would be greater than or equal to 10. Very good. Go ahead and finish solving this one. There are fractions and decimals in this problem, and what did we agree was easier to work with? Fractions. And that's a really easy fraction, decimal, to make it into a fraction. So go ahead and do your problem in fractions. We are going to solve it the same way we've been doing for all the other problems. Subtract the constant away. 0.5 is half, so I'm subtracting half from both sides. And then divide both sides by 2/3. Nine and a half. I'm going to make that improper to make my dividing easier for me. So 9 times 2 is 18, plus 1 is 19 over 2. divided by 2/3, which is 19 over 2 times 3 over 2. And what was your final answer here, Aiden? How about your inequality symbol? Very good. Now let me ask you this question. Can we have a fractional part of a day? Aren't we in the middle of the day right now? Right? It's not exactly the end of the day. Right? It's okay to have a fraction part of a day. So your answer doesn't need to be rounded or anything. You can leave it that way. We can say it rained for at least 14.25 or 14 1/4 more days. Right? Because usually it doesn't even rain the whole day. It just rains for a little bit and then it stops. Right? Mm-hmm. You could. Yeah, you can say 14 days and then however many hours. That's a good idea too. But we don't have to go that far for this problem. Any questions about number 3? Okay, let's talk about number 4. Maria is starting a small DVD business online. She makes $2.25 on each DVD she sells. To start her business, though, she had to invest $750. How many DVDs does she need to sell before she starts to make a profit? First thing I notice here is there's only 2 numbers this time, right? Let's think about, what do we know? Do we see any keywords that we're used to picking out here? Right, and that word each, we want to say that is something that's changing, right? Each DVD. And then we also can help ourselves by looking at the question. What is it asking? How many DVDs? So that must be our X term. We want to know how many DVDs, and she makes $2.25 per DVD. Yes? So this is our X. She had to invest $750. If that's how much money she has to spend to make this business, what do you think that's going to be? A constant or a total? A total. That's how much money, all her money that she had to put in to make this business happen. So how do you think we're going to set this problem up? Not equals. We want to make a profit. So do we want to sell more DVDs or less DVDs? More. So greater than or less than? Greater than? Greater than. Do we want it to be greater than or equal to, or just greater than? Greater than or equal to. Because do we want it to be or equal to? Do you want to break even, or do you want to make a profit? When you have a business, do you want to put in some money and get exactly the same money you got back, or do you want to make money off of it? So do we want greater than or equal to, or just greater than? Just greater than. Good. So we want it to be 2.25x is greater than 750. Because the question asks, how many DVDs does she need to sell before she makes a profit? So she wants to sell as many DVDs as possible to make money, right? Okay, so this is just a one-step inequality. Go ahead and just divide it. So we're going to divide both sides by 2.25. So that looks like this. 750 is the top number, so that's going to be my inside number. And then 2.25 is my outside number. I need to move that decimal point, don't I? So what we're really doing here is multiplying both numbers by 100. So there's 2 more zeros here. And then, obviously, none of us has memorized how many times 225 goes into 75,000. But remember that trick I taught you. Look at these numbers here. 2 goes into 7 how many times? 3. So I'm going to pick 3 as my starting point and see if that fits. 225 obviously doesn't go into 7. So I'm going to skip this spot. Doesn't go into 75. I'm going to skip that spot. 225 goes into 750, this whole thing. So I'm going to work with that third digit there. That's where my 3 goes. Okay? So that's going to be close to 700 something. Go ahead and finish dividing. If you haven't already. This division problem ends up being 3, 3, 3, and then that finished off the division, right? Point, I had to bring down a 0, and I got another 3, and another 3, and another 3, so 333.3 repeating. You could write that as a fraction, 333 and 1/3. And that would be your math solution to this inequality. But let me ask you, can you sell somebody a fractional part of a DVD? You're like, oh, you got a few cents? Let me, break off a piece of this DVD for you. Here you go. Can we do that? No, I think your customer would be pretty upset with you, right? If you broke a DVD and you're like, here's a piece of it. So in this case, we do need to round our sentence answer. Your math solution answer is going to stay like this, but your sentence needs to make sense to answer the question. So are we going to round up or round down? What do you think? Up. Again, she wants to make a profit. So you want to round up and be like, okay, you need to sell at least this many DVDs to make money. If you round down, then you're cutting yourself short a little bit, right? You're not quite making enough money to break even. We want to sell 334 DVDs or more to make a profit. Does this make sense? Okay, number 5. David owns a yellow cab, which is like a taxi, and the company charges a flat rate of $2.50 for every cab ride, plus 75 cents for every mile you go. He figures he needs to average about $12 for each ride to make a profit. He's trying to make some money here. How many miles, at least how many miles, must the rides average so he can make a profit? The question's asking how many miles. Do you see another keyword in there that tells us what the X term is going to be? Per, good. Per. How many miles will be per mile? So that's going to be our varying thing. When you go into a cab, you're not just going to go exactly 1 mile and then get out of the car, right? Depends on where you're going. Takes longer, takes shorter. So this is your varying item here, per mile, so that will be your X. And then the flat rate, if you don't know what flat rate means, that means that you pay that amount and it doesn't change, no matter what. So this would be your constant, 250, and then at least 12. How do you write at least as an inequality symbol? Greater than or equal to. So this should look like 0.75x plus 2.5 is greater than or equal to 12. You can have the x term first if this makes you more comfortable like this. Go ahead and solve this one, please. We are subtracting the constant from both sides, then dividing both sides by the coefficient. And we have x is greater than or equal to. Who wants to share their answer? Carlos? Good, 12.6, and then the 6 kept repeating. But we don't usually say a repeating number when we're talking in regular life, right? But we can say in fractions. What would that be as a fraction? Not 6/10, because that would be 6, 6, 6, 6, 6, 6, 6, not just 6. So not 6/10. 2/3. So before you bring down a 0 when you're dividing, that remainder is going to be at the top there. 12 and 2/3. And again, I'm going to ask you, can we have fractional parts of a mile? Is that okay? Or do you have to like, oh, I'm not done with the mile yet, I have to stay in the car? Or can you get out of the taxi whenever you want? Whenever you want, whenever you're done traveling, right? You're not just stuck to like every single perfect mile. So fractions are okay if we're talking about miles. So your sentence might be something like, anyone want to share? At least how many miles does he have to make the rides average? Scott? Very good. That's a very good sentence. The rides must average 12 2/3 miles or more, or David has to drive at least 12 2/3 miles to make a profit. Those are both good sentences. Any questions? One more. Catherine is 5 years old, and she's super excited to ride all the rides at the amusement park. But she's only 42.5 inches tall, and one of the rides she wants to go on says that she has to be at least 50 inches tall. So you want to tell her in about how many years she'll be able to go on all of those rides. So you do a quick Google search, and then you find out that the average child takes about a year to grow 2.5 inches. So she grows, most people grow 2.5 inches per year. So you want to tell her how many years will it take her until she can ride all the rides. So what are the things we know here? Good. This is our per something, per year, and then the question also says how many years. So what do you think this term is going to look like? Yeah. 2.5x. Then we also know how tall she is. Is that going to change in the next 5 minutes? Nope, that's pretty constant. For you're talking to her right now. She's not going to have a couple inches growth spurt in the next 5 minutes. So how tall is she? 42.5. So this is going to be our constant. And then what is the total number of inches that we are aiming for here? 50. What's the symbol I need to use? How do you translate at least? Greater than or equal to. You can be exactly 50 inches tall to go on the ride. You're like, yes, I made it. I'm tall enough. Or obviously you can keep growing and still be able to go on that ride. Yes? They're not going to be like, oops, you're 51 inches, you're too tall. Right? You can be an adult taller than that and still go on the ride. So go ahead and solve this problem. Subtract constant, divide by coefficient. These are fractions and decimals, but again, we like fractions, and those decimals are easy ones to make fractions. So we have x is greater than or equal to 3. How do I write that as a sentence to actually answer the question? Good. She can ride all the rides in 3 or more years, at least 3 years. No less than 3 years. Those are all good. Any questions about what we learned today? Okay. Number 1s, would you please share first? Then number 2s, take your turn. What'd you learn today? Ready? Share.